Merhaba. That's the only word in Turkish I can say. So, thank you very much, first of all, to the organization team for the chance to give a presentation here. I want to talk a little bit about different trends in a lightweight industry for the automotive industry and what the company KraussMaffei can deliver for that. Just to give you a brief overview, so I want to give you an overview of the lightweight technologies of KraussMaffei, and then I will talk just some few slides about the different technologies we have, which is not too easy to do in 15 minutes, yeah, but I'm quite sure I will be able. I have a clock here, which is good. So, KraussMaffei offers different lightweight technologies, and we are a machine building company. That means we come either from the thermoplastic side, which would be, for example, short glass fiber injection molding. And on the other side, what we have already heard today from company Engel are these RPM technologies, like the resin transfer molding. So, just a brief overview again. These resin transfer molding technologies and parts, of course, we just heard it, give you excellent mechanical properties, but at the same time, the cost efficiency is limited due to the curing time of your resins. On the other side, injection molding gives you limited mechanical properties, but at the same time, giving you a very good cost efficiency. And we also have this Fiberform technology, so organosheet back injection, which gives you the best out of two worlds, I would say. Let's start with the high-pressure injection molding with the RTM process family. So there are different RTM processes in the market. We developed together with BMW this high-pressure resin transfer molding process to the series production stage. We have already shown this TRTM, thermoplastic RTM. We have already heard from the colleagues at Engel. And the very new wet pressing technology, I want to also use some words. So, this high-pressure resin RTM, what you basically do, you build up a stack out of carbon fiber layers. You put it in a press to produce a preform, and you put that preform into another press. You can suck vacuum if necessary, and then you inject your resin. You can do very complex parts, and I don't want to use too many words about that because we have heard it in different presentations today. What are typical parts are, for example, underbody structures or seat structures, and basically, we have heard in the last speech we heard some minutes ago, epoxy resins in combination with these carbon fibers really have proven that it's a good substitute within the car structures of the structural parts in the car structure. Now, what is wet pressing? Wet pressing, in the KraussMaffei understanding, also belongs to this resin transfer molding technologies. What we do here, we apply the resin on a textile in an open mold, which you can see in picture number 4. So we have, let's say, more easy, simplified tools, and then we put it inside the mold, and by mold closing, we press the resin material inside the textile. What are the advantages over high-pressure resin transfer molding? Especially, you have no cavity pressure, meaning that you need less press forces. And as we, I think, all know, is that the tonnage of the press is the most cost driver in the complete process. So this is why the OEMs like BMW, they more or less want to substitute any high-pressure RTM process with wet pressing because just the investment is much lower. Here I can show you some typical parts. We have already seen before in the BMW i8, a floor reinforcement, in the 7 Series and in the roof sector as well. And a funny story is that the company BMW is even able to bring the company Engel and KraussMaffei together in one machine. So this is really, I think, only what German OEMs are capable to do. But I think together we have proven that there are different parts possible with this RTM process. Let's switch to the Fiberform technology, which is now a thermoplastic lightweight technology at KraussMaffei. What we do with Fiberform, we combine the injection molding together with the thermoforming of textiles. And here we try to make the best out of two worlds. The injection molding process gives you an excellent components complexity, but as I said in the beginning, only gives you, let's say, limited mechanical properties. The thermoforming of textiles gives you very good mechanical properties, but at the same time, the components complexity is limited. And with the Fiberform technology, we try to make the best out of these two worlds. When I think now, there are 2 or 3 slides missing in the end, which I had for this wet pressing and HP RTM. Do you want, still no one understands me, this is a problem? Okay, no, sorry. Okay, I just continue, don't matter. Perhaps, where's Canan, Mrs. Erdogan? Is she here? There are some slides missing which are very good, so I want to show them. Should be actually exactly after these slides, yeah. Thank you very much for helping me. Whatever you have, I've just brought you my slides, I don't know, 1 hour ago, but doesn't matter, I will just continue. So perhaps I just try to make it in words, yeah. So Mr. Chagatai from Bloomberg, he has said in his speech that he believes that the future for these lightweight plastic materials for car manufacturers would be the combination of high-strength metals and aluminiums, so aluminium lightweight, and plastic reinforced parts. And I absolutely agree with his opinion, because I think the BMW I-theory is to build a complete car structure out of carbon fiber textiles might, in my opinion, not be the best way to do it. But if you, no, everything is gone. And now, but if you compare with the 7 Series, you have every technology where it really makes sense. So you have your high-pressure RTM technologies as a B-pillar reinforcement, for example. Then you have different thermoplastic technologies. So just make use of each technology where it really makes sense in the car. And I think I really have the same opinion like Mr. Chagatai from Bloomberg here. Okay, sorry for this short interruption. Let's come back to Fiberform. What we do with Fiberform here, we take such an organo sheet, which is a semi-finished fiber-reinforced part. We take it, we heat it up over melting temperature, most likely with an infrared heating system. And then comes the most critical process step. We need to take this hot organo sheet inside the mold. By mold closing, we thermoform this organo sheet, and then we directly back inject the material, and we get out a final part which we can directly build into the car. I think there was also one slide, but whatever. Let me talk a little bit about our technology, the injection molding compounder, the IMC, which we now have for many, many years. What we do here is we combine injection molding, which is a continuous process, discontinuous process, with the extrusion technology, which is a continuous process. How we do it, you can see it here. We have an extruder, a twin screw extruder sitting above an injection piston, and we basically do this for saving material costs. Yeah? So if you think you would process such a fiber-reinforced pelleted material with 8 or 12 millimeter in length, that costs a bit of money. And if you directly process fibers and plastic material inline on your process, you are able to save money. On the material cost side, of course, this technology is a bit more complex than easy injection molding, but in the end, it really trades off. Again, a slide is missing, sorry. Okay, so it's really hard if like half of the slides are missing. What I wanted to talk about, you can see it here, is the process combination with cell form, MuCell, which is physical foaming. Yeah? And we can combine this physical foaming process with the IMC. So we use that basically for flat parts, very large area flat parts, which tend to have problems in dimension stability, so warpage problems. And with the combination of our IMC with cell form, we are able to have parts which are perfect dimension stability, and at the same time, we have the cost-saving potential of the IMC combined in one process. We have first customers who build it for one of the major OEMs in an underbody car structure in a, let's say, premium class OEM. Colorform. With Colorform, I want to finish my presentation. Colorform is a combination of standard injection molding with a lacquer system being injected afterwards. So that means in the first cavity of the tool, you have your thermoplastic base carrier. Then you have a 180-degree turnable inner tool. And on the other side, we inject the lacquer system. The benefit is you do not have any painting processes afterwards, but you can directly produce the material in one mold. And this thermoplastic base carrier never leaves the mold, so that means you get a very good complete finished and varnished parts, and of course less logistics as well. Here we have the slide, great. So this is the world's first serious application for our Colorform technology, an A-pillar paneling of the new Peugeot 3008 SUV, and hopefully more to come. Yeah, teşekkürler, that's the second word I can say. Okay, thank you very much. I have 3 minutes left because a lot of slides were missing. Yeah, so perhaps we can have a talk later. Okay?
Okay, please.